Have you ever looked at a pump spec sheet and seen the words bare shaft and wondered what that actually means? You're not alone. In industrial fluid handling, the term gets used constantly. But a surprising number of engineers, procurement managers, and facility operators aren't entirely sure what sets a bare shaft pump apart from everything else on the market. In this video, we're going to fix that completely. We'll cover what a bare shaft pump is, how it works, what's inside it, the different types available, the pros and cons, where they're used, and how to choose the right one for your system. Whether you're specifying equipment for a new project, replacing something in the field, or just building your technical knowledge, by the end of this video, you'll have a clear, confident understanding of bare shaft pumps. Let's get into it. So, what exactly is a bare shaft pump? Here's the simplest way to put it. A bare shaft pump is a pump supplied without a motor, without a baseplate, and without a coupling. It's just the pump itself, the hydraulic core of the machine, delivered as a standalone unit. Now, the name tells you exactly what you're getting. When the pump arrives, the drive shaft, the rotating rod that sticks out of the casing, is completely exposed. It's bare. There's nothing attached to it. No motor. No coupling. Just a shaft, waiting to be connected to whatever driver you choose. That's the key idea. With a bare shaft pump, you are responsible for selecting and sourcing the motor, the baseplate, and the coupling separately. The pump manufacturer gives you the hydraulic machine. You decide how it gets driven. Now compare that to two alternatives you'll often see. A close-coupled pump is one where the motor and pump share a single shaft and a single housing. They're essentially one combined unit. There's no separate coupling required, and everything is compact, but you have very little flexibility in how the pump is powered. A packaged pump set, on the other hand, includes the pump, the motor, the baseplate, and the coupling, all pre-assembled, pre-aligned, and supplied together as a complete package. It's convenient, but again, you're locked into whatever the manufacturer has specified. The bare shaft pump sits at the other end of that spectrum. Maximum flexibility. Maximum control. But also more responsibility on your end. Just because it's called bare doesn't mean it's incomplete. A bare shaft pump is a fully engineered, fully functional hydraulic machine. Let's walk through what's inside. First, the pump casing, also called the volute. This is the outer housing. It contains the fluid and is shaped, usually in a spiral, to collect the high-velocity fluid coming off the impeller and slow it down, converting that velocity into pressure. The geometry of the volute is carefully engineered to minimize turbulence and maximize efficiency. Second, the impeller. This is the rotating heart of the pump. The impeller spins at high speed and throws the fluid outward using centrifugal force. Depending on the application, the impeller can be open, semi-open, or closed, and that choice depends on what you're pumping: clean water, slurry, viscous chemicals, solids-laden fluids, and so on. Third, the pump shaft. This is the rotating rod that transfers power from the external driver to the impeller. In a bare shaft pump, this shaft extends out of the casing, and that exposed end is what gets connected to the motor via a coupling. It's literally the bare shaft the name refers to. Fourth, the bearing assembly. Bearings support the shaft, keeping it in precise alignment as it spins under load. Most industrial bare shaft pumps use rolling element bearings, either grease lubricated or oil lubricated, housed in a dedicated bearing bracket attached to the casing. Fifth, the mechanical seal or packing. Where the shaft passes through the casing, you need a sealing system to stop fluid from leaking out along the shaft. This can be a single mechanical seal for standard fluids, a double mechanical seal for hazardous or toxic applications, or traditional gland packing for less critical duties. And finally, the backplate or stuffing box. This structural component connects the wet end, that's the casing and impeller, to the power end, the bearing housing. It also supports the sealing arrangement. So as you can see, there's nothing simple about the engineering inside a bare shaft pump. It's a precision machine. It just doesn't come with a motor. The operating principle of a bare shaft pump is exactly the same as any centrifugal pump. Here's how it works, step by step. Step 1. Fluid enters the pump through the suction port. The spinning impeller creates a low-pressure zone at its center, called the impeller eye, and that draws fluid in from the suction pipe. Step 2. As the impeller rotates, it accelerates the fluid outward using centrifugal force. The faster the impeller spins, the more energy it transfers to the fluid. Step 3. That high-velocity fluid is collected by the volute casing, which slows it down. As velocity drops, pressure rises. That's the conversion from kinetic energy to pressure energy, the fundamental principle behind all centrifugal pump operation. Step 4. The now pressurized fluid exits through the discharge port and flows into your downstream piping system. The critical difference with a bare shaft pump is where that rotational energy comes from. In a complete packaged unit, the motor is right there, directly coupled to the pump. In a bare shaft pump, the energy comes from an external driver, an electric motor, a diesel engine, a steam turbine, a gearbox, a hydraulic motor, whatever is right for the application. That driver is coupled to the bare shaft via a flexible or rigid coupling that you select and install. Let's do a quick side-by-side comparison, because this is where the practical decisions really come into focus. A packaged pump set includes the motor, baseplate, and coupling. It arrives pre-aligned from the factory. Installation is simpler and faster. It's ideal for standard, off-the-shelf applications where you don't need a lot of customization. A bare shaft pump comes without any of those extras. You source them separately. Installation requires on-site alignment, which takes more skill and time. But the upside is enormous flexibility. With a bare shaft pump, you can pair it with any motor that fits, a high-efficiency model, a variable speed model, an explosion-proof motor for hazardous areas, or even a non-electric driver. You can design a completely custom baseplate for your space constraints. You can choose exactly the right coupling technology for your application. And if your motor fails, you replace the motor. The pump stays in place. Vice versa if the pump needs work done. From a cost perspective, the bare shaft pump itself is cheaper up front because you're only buying the hydraulic assembly. But factor in the motor, baseplate, coupling, and installation labor, and the total cost can be comparable to a packaged set, or higher, depending on complexity. The real value isn't just cost. It's control. Bare shaft pumps are not one-size-fits-all. They come in several configurations, each suited to different duties. Centrifugal bare shaft pumps are the most common by far. The standard end-suction centrifugal design is found everywhere: water treatment plants, HVAC systems, irrigation networks, industrial process lines. If you picture a bare shaft pump, this is probably what comes to mind. Split-case bare shaft pumps handle higher flow rates and higher heads. The casing splits horizontally or vertically, making impeller access easier for maintenance. These are common in fire protection systems, large HVAC plants, and municipal water networks. Vertical turbine bare shaft pumps are designed for deep well or wet pit applications. The pump column and bowl assembly go below the surface, but there is no motor on top. The buyer specifies a surface motor matched to the available power supplied. Chemical process bare shaft pumps, built to ANSI or ISO standards, are used in refineries, petrochemical facilities, and pharmaceutical plants. These applications demand specific materials and seal configurations that factory-packaged units can't always accommodate. And slurry and solids handling bare shaft pumps are the workhorse of mining and minerals processing. They're paired with variable speed drives or gearboxes that manage the severe, abrasive duty cycles those industries demand. So why do engineers and system designers keep coming back to bare shaft pumps? Let's run through the key advantages. Advantage 1, driver flexibility. This is the big one. You can power a bare shaft pump with virtually any driver. Electric motor, diesel engine, turbine, hydraulic motor. the pump doesn't care. For remote installations, unusual power infrastructure, or applications demanding non-standard speeds, this is invaluable. Advantage 2, lower initial cost. You're buying just the pump assembly. If you already have a compatible motor sitting in your stores, or if you're dropping the new pump into an existing skid, you avoid the cost of the complete packaged set. Advantage 3, fully custom system designed. System integrators love bare shaft pumps because they can build exactly what the project needs: the right baseplate material, the right coupling, the right motor frame, arranged exactly the way the installation requires. No compromises. Advantage 4, easier maintenance over the long term. Pump failed? Replace the pump. Motor burned out? Swap the motor. Because they're independent units, you never have to replace equipment that's still perfectly serviceable. Advantage 5, speed flexibility. Pair a bare shaft pump with a variable frequency drive and you can adjust pump speed, and therefore flow rate, across a wide range. This is simply not possible with some close-coupled designs. Advantage 6, standardization across a facility. Large plants often specify one bare shaft pump model for multiple duties, varying only the motor size. That means fewer unique spare parts, simpler maintenance planning, and faster emergency response. No technology is perfect. Here's what you need to be aware of before specifying a bare shaft pump. First, installation requires expertise. Shaft alignment is critical. If the pump shaft and motor shaft are not in precise alignment, you'll see premature bearing failure, seal leaks, and excessive vibration. This requires skilled installation technicians and proper laser alignment tools. Don't cut corners here. Second, more components to manage. You're not buying one item, you're buying several. Motor, baseplate, coupling guard, and any ancillary equipment. That means more purchase orders, more lead times to coordinate, and more things that can go wrong. Third, no factory pre-alignment. With a packaged pump set, alignment is done at the factory under controlled conditions. With a bare shaft installation, alignment happens on site, after mounting, in real-world conditions. It must be done right. And fourth, compatibility is your responsibility. You need to confirm that your chosen motor's shaft diameter, frame size, and power rating are all compatible with the pump's coupling requirements. Get this wrong, and you have a very expensive problem on your hands. Bare shaft pumps show up in almost every industry that moves fluids. Here's a quick tour. In water and wastewater treatment, they handle clarifier feeds, filter backwash cycles, and sludge transfer. In HVAC and building services, they circulate chilled water, condenser water, and heating fluids through large commercial and industrial buildings. In oil and gas, they manage produced water handling, pipeline transfers, and process cooling. In chemical and pharmaceutical plants, they move acids, solvents, and process fluids through systems where material compatibility is non-negotiable. In agriculture, they power main irrigation stations and booster sets for drip systems. In mining, they transport slurries, do water excavations, and circulate leach solutions. In power generation, they handle cooling water, condensate, and boiler feed duties. And in food and beverage, hygienic bare shaft pumps handle product transfer, clean-in-place systems, and pasteurization circuits. If fluid is moving industrially, somewhere nearby, there's probably a bare shaft pump. Choosing the right bare shaft pump comes down to a clear, step-by-step process. Step 1. Define your duty point. You need two numbers, flow rate and total dynamic head. Flow rate is typically expressed in gallons per minute or cubic meters per hour. Total dynamic head, in feet or meters, captures all the pressure the pump needs to overcome. These two values are your starting point for everything. Step 2. Understand your fluid. What are you pumping? Water is easy. But what's the viscosity? The temperature? The specific gravity? Are there solids in suspension? Is the fluid chemically aggressive? The answers drive your impeller type and your material selections. Step 3. Check the system curve. Plot your system's resistance curve against the pump's performance curve. Confirm that the pump's operating point, where the two curves intersect, sits at or close to the pump's best efficiency point. Operating far from BEP wastes energy and shortens pump life. Step 4. Specify shaft and coupling requirements. Know the pump's shaft diameter, keyway dimensions, and shaft overhang. Match these to a compatible coupling and motor frame. Don't assume, verify. Step 5. Select your seal and materials. Based on your fluid's chemistry and temperature, choose the right seal face materials, silicon carbide, tungsten carbide, or carbon, and the right casing alloy, cast iron, stainless steel, duplex, or exotic alloys for aggressive services. Step 6. Confirm standards compliance. Check whether your application requires compliance with ANSI/HI, ISO 5199, API 610 for petroleum services, or NFPA 20 for fire protection. These standards define dimensional interchangeability, minimum performance requirements, and safety criteria. So, to wrap it all up, a bare shaft pump is a pump supplied as a hydraulic assembly only, no motor, no baseplate, no coupling. The exposed drive shaft gives it its name. And that bare shaft is exactly where its flexibility begins. For engineers and buyers who need control over driver selection, system layout, motor efficiency, operating speed, and long-term maintainability, the bare shaft pump is often the smartest choice available. It demands more from the buyer up front, more decisions, more procurement work, more installation precision. But in return, it gives you a system built exactly the way your process demands. If you found this video useful, make sure you subscribe for more practical engineering content. And if you're working on a pump selection project, drop your questions in the comments below. We'd love to help. Thanks for watching.